Okay, so then with that said, I feel silly introducing Alexey because we've introduced Alexey several times and everyone already knows him. But I do have to comment, he's doing absolutely amazing work chairing the 3D Formats Working Group. I know how hard that is to do it at a much smaller scale compared to what Alexey is doing. And I'm very impressed with the scale that is executing, the scope of some of the things that they're breaking off. Then Alexey, I would ask, so I know we're a little shorter than usual, but the rest of the time is yours and any watercolor for sure. And then when you introduce yourself, I believe you're working on a book, right?
Work on what? Sorry, can you?
But yeah, if you could tell us about any of your writing projects as well, I think we'd be interested. So
This is weird name because that was supposed to be two different presentations. We kind of squeezed into single one. That will be a couple of slides of glTF audio. Just don't take this. And mostly it will be glTF roadmap. And again, I will extend what we're doing for audio as for today for a couple of slides, a little bit more deeper into technical details. Again, hello, I'm Alexey Medvedev from Meta. Also, yes, Khronos chair for 3D formats. Thanks, Patrick, for introduction. And yes, let's go. So basically, glTF is well known for PBR materials. It's a kind of first standard that tried to express the PBR's properties as the set of the kind of PBR as the set of properties, not trying to enforce any particular implementation. We just choose the model as metallic roughness, and based on this, we build like a layers of the complexity on top of the standard model. And we're not going to change this. If you have any specific questions, we have all the experts here actually in the call, so feel free to ask if you want more details in this. But as you can see, we present the way how we introduce new features as some sort of wave. So the 2017, that was the base layer and then base model, sorry. And then we introduce additional extensions, again, like a wave approach. So wave 5 is coming, what I'm trying to say. For the wave 5 is most likely next year. We'll get the diffuse transmission and surface scattering. And those are heavily in development as today. And we feel pretty much optimistic that it will be done pretty much soon. So the next one, we understand the value of interoperability and just extensions in general. We see a lot of effort from industries such as OpenPBR and MaterialX as a particular example how it can be utilized. We're trying to make everything inside our ecosystem friendly to the rest of industry. And we feel the MaterialX is the way to go. And as today, you can use glTF PBR material node in MaterialX as is. Our goal is actually to invest even a little bit more into this, make sure the MaterialX implementation will be up to date to all the ratified PBR extensions. It's still not there yet, but it's planned for the next year. And that gives us actually the confidence we can evolve with the industry. For this, we have another new extension in common that we call glTF procedural textures. So it's not only MaterialX node that you can use glTF PBR. Actually, we have the way that you can add customizations and flexibility for the actual glTF PBR model. So that literally means for each material channels and inputs, you can identify the procedural shader graph that you can control some parameters. It's not exactly, it's a subset of MaterialX features. So like literally everything that you're doing with the glTF procedural textures can be converted into MaterialX representation and supposed to behave the same way. It's not in reverse. We are not allowing to express all the feature set of MaterialX into glTF. But we have some discussions about the future evolution of this, so we kind of open for the possible use cases. I will touch this a little bit later in the following slides. Spatial computing, I think it's one of the biggest directions for us for glTF future. It's not the spatial, but like the keyword is not spatial. It's more like a computing actually. And we think glTF future is maintenance the core values, keep it lightweight and simple and well described as usual. But meantime, we want to add extended capabilities into this. It's sort of smart asset, and we have several directions that includes many actually extensions for this to make it happen. First of all, it's interactivity. We are introducing node-based graph handling for the user actions and events. So that's kind of one of the use cases, but in reality, we introduce the actual compute model for node that can be described as the node-based graph. Then we are actively working on the complex scenes as the referencing of glTF assets. It's still in discussions, still many questions open. I know we present this a while, but still, well, we're trying to be thoughtful about this, not rushing and just introduce something. We want to be, we want to create something for the ages. Also, we're working on the physics that it's, again, in the following slides, I will go slightly deeper in this. And then audio as well. It's a new approach, how we can express audio, specialized, non-specialized audio in the glTF assets. So, interactivity. It's a new portable description for the actual flow graph that we can introduce. Again, compute model. We use the distillation of the engine, the typical game engines practices. So if you're familiar with Unity or Unreal blueprints or action graph from the NVIDIA Omniverse, that's probably you understand what we're talking about. We provide the flexibility to address glTF internal properties, mutable ones, and use to update them and animate them. And that basically allows to implement simple interactive applications, such as like really simple games or education or something else, or e-commerce, for example, some sort of configurators, etc., etc. To make it happen, actually, surprisingly, just glTF node description was not enough. I mean, it's not surprising, but along the way, we brought a bunch of different extensions to just make it happen. One is I really want to highlight here is a KHR animation pointer. That means you can use the string URI to address all the properties of the glTF internals. And that basically gives all this flow graph capabilities to control the internals. And then along the way, we kind of figured out that probably you want to control the actual scene. So introduce this node visibility, selectability, variability, and accessor float 64. That was like a maintenance, basically the way you want to address doubles in the glTF internal, sorry. Next one, glTF physics. glTF spirit is generalize and find the common ground between different solutions. So physics basically feeds the same pattern here. We want to express the physical properties of the assets in the platform independent way. So we introduced two extensions. One is allows you to describe any sort of collision mesh in a procedural manner. And second one actually introduced the actual rigid body dynamics that you can provide to your existing physics engine, and will start to behave as actual real world object. So this GIF shows you the way it's just like literally one asset, and it has the physics intention, and you can simulate this complex scenarios. This is big topic. So external references. Yes, we're discussing this at least for a year plus. And the goal is, the spirit is pretty much obvious. We want to combine multiple glTF assets in the complex scenes. We want to make this efficient. It's not like we don't want to solve all the problems along the way. We don't want to step on the USD toes here. We don't want to create the complex layering system or something like this. We want to solve for the specific use cases, such as placements, LODs, different ways of variants for the meshes or materials, or reuse on the resources, or cache reuse, cache efficiency for the browsers, you name it. And it's sort of still, as far as we're trying to not overcomplicate this, it's still many questions need to be asked. So we have this URL at the bottom that we trying to discuss all this matter. It's still, I assume we can easily say that still in early stage of development. Our priority is now to finalize interactivity first, and then same TSG, we switch over to start to discuss external references more seriously. Again, it takes a while just because it's super complex problem, and every time when trying to discuss this, we are understanding we need to spend more time to think about this. glTF audio, future audio graph. It's a new extension that some people, including myself, were working on. This is a superset of proposed audio extensions such as KHR audio emitter and already published MPEG audio spatial, including PEG media. And thanks to Nick, we kind of, we did this normalization path with web audio. If you check the current description of the nodes and everything around this, it's pretty much has 80% of similar names and 80% of the expected similar behavior. That's a slight divergence, just because for the sake of the extension and how we want to train the actual assets this way. So, but the goal was actually, mental model was get the extension and it should be transpilable into web audio. And I think that's the way. So you literally can get any graph and it can be converted into web audio code. But it has additional features as specialized properties, which is obviously impossible to introduce for web audio, and that serve the actual spatial needs. Well, it's a similar approach as procedural textures or interactivity. We standardize the way to represent audio graph that will be consisted as the interconnected audio nodes, that you can create the final audio output, and designed for managing audio routing, mixing, and processing. And you can store this as the part of the glTF asset. Really quickly about the concept. So those are concepts. We have the concepts of audio nodes, and that literally means you have the source. The source can use the audio data from internal or external sources as the popular audio formats. It can be addressed as the external file, it can be addressed as the glTF accessor, or we providing the oscillator node that allows you to generate the signals for you.
Alexa, I'm
Then,
sorry if I could jump in for one moment. Did you say do you not have any slides for this?
for what?
The audio here, I don't see slides shared on my screen.
Really? So
Oh, you know what? No, actually, it's a new version of Zoom. My apologies. I guess I have a tab where I cannot see the slides. Sorry, carry on.
yeah. So I show the slides all the time, but yeah, okay. Yes. Anyway, we have a emitter, two types of emitters. One is specialized and another one is non-specialized. Again, non-specialized, easily transferable to web audio representation. Specialized has all these additional properties regarding the transformations, all this kind of spatial information, etc., etc. And we have, obviously, we have a listener. Along the way, we have audio processors. That's a specific nodes, and yeah, you can, I assume, read it from the screen. And then we have the set of the filters, and then we have a reverberation node. Important part here is, so design this way that you can control the flow from the interactivity if necessary. So obviously you can control the actual playback as the plays, pause, stop, etc. The controls, but for all the audio processor nodes, you have the several ways that you can control them as well. For example, if you want to bypass, we have the bypass value that you can control. In this case, this node would be disabled. And then that allows you to create some sort of dynamic representation of the audio graph, but it's still controllable. We follow in the spirit of the interactivity and procedural textures. That means we have no dynamic allocations. Everything is described upfront and defined upfront. So that kind of gives you control over the execution flow all the time. And speaking of the audio graph itself, it's expressed as DAG. So it just, again, follows the same rules. Tooling. We are spent enormous amount of effort for support all our internal projects. Actively develop and maintain Blender and Sample Viewer. We have glTF compressor tool that allows you to, again, optimize your assets, which is extremely important for web applications. We have external references, sampler viewer actually already as well, that you can load the complex scenes and play with them. We have a bunch of outreach events, and then procedural texturing. That's an ongoing process for us. We want to create the tool that allows you to, again, probably generate them. So our plans for the 25, the biggest one, we want to spend a lot of effort on the test suite. The new incoming extensions, such interactivity, physics, audio, etc., just bring enormous amount of the complexity into the ecosystem. We want to be prepared. We want to make sure we, and which is even more important, industry can test it out. So that's our goal, to bring the tools along the way to make sure we are not breaking ecosystem. And yeah, it's expected we'll keep maintain all our project as glTF configuration, not conformance, then Blender and Sampler Viewer. And we want to keep going with the KTX, including discussions, how we picture this, because KTX some sort of bounded to glTF, but we want to untangle this and kind of present KTX as the slightly bigger scope project for the industry. And yeah, obviously there will be a lot of outreach. And this is our glTF roadmap overview. I want to emphasize several things. So short-term roadmap, that means everything here, it's almost done, close to done, or will be done pretty much soon. We expected to finish some stuff this year. Unfortunately, we kind of keep going the next year, but it does not change. Then, I mean, doesn't change our approach for this. But for roadmap discussions, we have several ideas that probably we want to go, but we are not sure if we really want to do this, or is it too early? Gaussian splats and NERF, that's kind of the example that we taking this seriously. We're closely looking what industry is doing. But because glTF values, again, it's kind of, we want to keep legacy for 10, 20, 30 years. There's obviously some questions, should we go this way or not, because we feel it's too fresh. It's not immature, but it's probably not kind of solved all the issues, so we can expect the changes. But we kind of keep going and keep discussing this. And for the roadmap discussions, what's the same? It's kind of long or sub-divs. Yeah, we discussed this for years. We kind of keep discussing this. It's hard to justify why we need this right now, and still open questions. But you can see the scope where we target at. So definitely looking for the input from the industry. What should be interesting for these reasons? I will definitely consider this seriously. And let me hurry up a little bit. So glTF is, a matter of fact, is a foundational standard, and we keep going this way. So we already ISO, we already part of PDF spec, we already heavily involved in the majority of the kind of listed here specs. Recently, we signed liaison with VRM and presented a lot of work about this. Well, that's our direction. So we want to keep going. And we want to improve the ecosystem in general. So like, I think it's just beneficial for everyone to use this standard and just try to find the common grounds and just improve everything regarding this. And that's pretty much it. And we have 3 minutes for the questions.
Alexey, that was awesome. That was, I think, the right level of detail and the right breadth. I wouldn't worry about the time here. So certainly we had 3 minutes left in the official meeting, but we'll roll right into water cooler. So if there's good conversation happening, let's keep it going.
Yeah,
so
I can stay a little bit longer if anyone has questions. Yeah.
No pressure. All right, who has the first question? So Alexey, are we getting a lot of adoption on the audio side? Or just, I'd say, early adopters?
Not at the moment. So the early adopters actually is Meta. That gives me the confidence that we are doing the right thing, because that's supposed to be adopted by the actual production team. And that means we will get the actual real use cases. And yeah, I'm really happy with this. My idea is actually probably when I'll get some spare time, I will just implement something on top of web audio, again, to show the way that we can easily convert and see if we get any traction on this.
And Alexey, maybe that leads into my next question, which is, for a reasonable implementation and maybe on the web where there's web audio, for a mortal programmer like myself, right? What's a level of effort? Is it, it's 3 weeks, it's 6 months?
I don't think it's super complex. So the glTF parsing is super trivial, especially for the web. And then if you want to use web audio as the actual audio engine, I don't know, maybe a couple of weeks max to implement everything. That should be pretty much straightforward.
Alexey, any platforms that are surprising you when you look at where glTF is being used, right? Like we started glTF for the web, then Microsoft came along and said, hey, let's do PBR because we want to use it on the desktop. And now clearly, you and many folks are using it on mobile. Is there any trend or anything that you're seeing?
I feel it's kind of everywhere, to be honest. So I don't think
That's a trend, and that's a trend in itself.
Yeah, that's a trend. We a little bit worry about the smart asset direction. It's kind of sometimes feels probably we are asking too much. And that's one of the questions we want to actually address with the industry, isn't too much or not. Because I think our dream is actually to see those new extension as the next step for the majority of the viewers. It would be really nice to bring this over. And that's why I'm personally really impressed by the interactivity and all the satellites around this constellation of this. It's like, it's actually kind of first step for the actual metaverse, right? And on some sort of, I don't think we're competing even like with USD, because it still can be really easily transferable and converted into more complex USD use cases. But that's the value of the glTF. It's like a really just enough information to make it happen. And the actual virtual machine that requires to implement the interactivity graph, it's not super complex. And as soon as you implemented like the KHR animation pointer, the way that you address the internals, you kind of open all the gate for really like a complex use cases, and they kind of shareable. I think as the software engineer, we always struggle. So we kind of like open source on one side. On the other side, it's kind of almost like invented not by yourself. So you kind of duplicate a lot of code, right? And when you want to share something like this complex use cases across the industry, either you force in the quote, either you force people to use your software, right? Which is, again, it's not easy in some cases, or you share the actual asset. In this case, we kind of open the gate for the actual compute. It's not just a 3D model anymore. It's a self-contained object that has the behaviors in it, like literally, like you can control this. And that's why I'm kind of really, really interested to see what's coming next. Like as soon as the main glTF supporters, like engines, viewers, etc., will support this, I think it's, again, it's like a really first small step for the actual metaverse. You can just load the assets, they probably will start to communicate to each other or something. It will be really fun to see how it evolve. And because it's like a so small, strict, and kind of controllable, I think the way to implement this is way easier. I mean, it's just like it's way less bar to just enter this direction.
Yeah, I agree. And then also a nice comment from Mikhail there saying, hey, being able to drag and drop GLB into PowerPoint is an impressive interoperability.
Yeah, yes, exactly. That's
So
the, yeah.
Alexey, just looking at the time, I just want to end the official meeting just in case anyone feels that they need to drop off, but then just keep rolling if you're able to stay for more Q&A and water coolers. So
Sure.
as always, Alexey, thank you very much.